Hello everyone, welcome back. In this video I'm going to show you how to define link and why do we use link, and then the second one is diaphragms. Now in Etabs, when we're modeling, it's very important to model correctly. So the grid line that we're specifying that comes from architectural plan not always are in the center of the columns, or in another manner, when we're modeling beam and column, the beams are not connected to the center of the column. They are shifted on the edge of the column. Now, since Etabs is using the joints to connect things together, if you shift a column from its original location, now let me just show to you what do I mean by this. This is not to show how to provide. Let's say I have a column here, and let's say I have a beam. Now this beam is starting from the center of the column. So the center of the beam, the joint that you see it here, it's linking the beam and the column. Now if it is this is the center of the column, and the beam comes directly to the center of the column. I'll discuss this modeling later. But the idea is what here? It's what will happen if I'm going to move this column. So if I move the column, let's say I'm moving the column by 0.05, 5 centimeters, let's say I'm moving this column. Now if I move the column, look, automatically the beam will move. Why? Because it says that this beam is supposed to connect it to the center of this column. But what will we do before modeling the beams? We do the columns, we move them, and later if you decide to put the beam, for example here, now this beam is not connected to the center of this. The joints are not connected. So if you have a case like this, in the modeling, you have to link those two joints in order for the load transfer to properly from the beams go to the column. And for the moment, for the rotation, everything to happen as we know it from the analysis of the structures. This is a joint between them, so the load transfer from one joint to another joint. So if you have a case like this, you need links, a rigid link, in order to connect those two together. So this is why we need link in Etabs, for many other reasons, but this is one of the commonly used case for link. Sometimes you're just linking two from far away from two things together. That's also possible. But the way that we used, if you have a case like this, when the column and the beam does not have the same center, the same connection point, you need to link those two together in order to present the real situation of the connection. So forget about this modeling here. I'm going to go to define. So this is the idea of it. We need section properties. We go for link support properties. Now link are kind of imaginary things. They don't have weight, they don't have mass. You can give it to them, but by default they don't have anything. So I'll add new property. I'll call this one rigid. So rigid, it's kind of linear. I'll leave the rest of the things we have. Mass 0, weight 0, no moment of inertia, rotational, nothing. And it's basically, I come here, we'll fix all of them. The directional property now, why they made it like this? Sometimes you just want one part of the things to be transferred from the one member to another member. So the link that they have it here, the directions, which is U1, U2, U3 means X, Y, Z directions, and the basically 1, 2, 3 here. So you can, the reactions, are you going to be fixing it? So it's going to fix one direction. It means that from that direction, the loads, the things will be transferred. For the case I want it here, I want everything from the column, the beams, to transfer to the column. So I'll fix all. That's what we call rigid. So you have semi-rigid, you have rigid, you have just one direction, X direction, Y direction, Z directions, that you can allow the loads to transfer from one joint to another joint. For the case we have it here, For the purpose of this building, we have it is simple buildings that we don't have a special case of transferring load. We'll go for fixing all of them. So we have a rigid link that we're going to use it later to join those connections if you have any shift in the code. This is, you need to define a link. So press OK. Now you have a link here which is rigid. I prefer to delete this one. So I only have one link which is rigid link that I can use it later for connecting the joints between the beam and column. This is one. The second thing that we're going to define is diaphragm. Now diaphragm will be given only to slab. In Etabs, slab design will be done by using finite element methods. So finite element analysis, different type of analysis that the program is using it. They're dividing the slab into like small. If you have a slab, they will divide this slab to smaller slabs. So kind of like this. They into mesh. We'll talk about this meshing later. So this is how the design of slab will be done in Etabs. So you will decide the mesh size. They call the mesh here. So it will be, in order for this is the way that finite element method is working. So you're dividing the element that you have into smaller portions and use numerical for analysis. So what will happen, each of those small will be considered as a small slab. Each of them will be considered a small slab. So those are the joints we have it. All those will be joints. Since Etabs is going to use this method for analysis and design, we have to make sure those joints in the reality they are moving together. If you apply force here, it does not mean that there is a joint there within the slab. No, if this joint here, for example, this joint move 1 millimeter, this is supposed to move 1 millimeter like this, and so on. So this is what the aim of diaphragm that we have to apply to the slab, because slabs will be designed with this analysis and design with this meshing. So will be applied to them. Now there's two type of diaphragm, rigid and semi-rigid. Semi-rigid mainly if you have cases when, let's say that you have a slab like this. Now this slab, if you apply load here, the other part, which is the second part of it, this one here, this is, let's say we have some meshing here. Now if you apply semi-rigid here, semi-rigid means that this part, it can bend like this. So if I represent some deflection of this shape, if I can manage it. So let's say applying load here, what will happen? It might happen like this, but this one will not move if it's semi-rigid because they are not linked directly. If you assume rigid diaphragm, if you apply here, even there is a space here, because you applied fully rigid, what will happen? The other part as well will be bent like this. So for some case scenarios, we'll go for semi-rigid diaphragm. If you see all the slab is connected together, you can go for rigid diaphragm. If you don't have any open areas that the slab can work differently, you can go for rigid. If not, recommended to go for semi-rigid diaphragm. The idea of diaphragm is what? To connect all the links, all the joints together in order to represent the real life of the slab, because this slab is acting as one. But if there is an empty area or something, no connection, so semi-rigid might represent much appropriate than a rigid diaphragm. So the idea of rigid diaphragm, if you have a slab, since it's using meshing, all of them will be joints. In order for this slab to move or to translate load from one joint to one joint, for the directional displacement, we need diaphragm. So diaphragm basically will find the center of mass of this one. There will be center of mass and will connect every single link to that one. So it will be something like this. You'll see it on the board. When we apply to the slab, you will see something like this. It will tell us that every single joint connected together. If one joint moves according to the direction the rest of the slab it's going to move. And we want this to represent the real life because hold the slab working together. So that's why we need to define diaphragm for the slabs. We have it here. Well, it's very easy to define diaphragm. So we'll go to diaphragms here. There is one by itself. We will go for add new diaphragm. Well, there's two diaphragms, that's it, rigid and semi-rigid. So I'll write this one rigid diaphragm. I'll press OK, and it will come here. I prefer to delete the other one because not to have any problems when you're assigning the diaphragm to the slabs. So this is, you can have another one semi to apply it for some. You can have both of them in the project. You can apply some slab rigid, some other slabs semi-rigid diaphragm. So you press OK. Now you have the diaphragm within the defining sections. Now some other things that here, I'm not going to come back to them, but in case if you are not using auto lateral load, auto seismic load, you can go for time history and response spectrum. Those are recorded real live seismics, so you can bring it from the database that each countries that they will. There is an international one that record all the, basically is for seismics, that you can bring it here and add it to the load cases. So in this case, you're going to use a real-time analysis that happens. For example, you are analyzing, designing for a seismic case that happens, for example, in Cyprus. So you can get the data and bring it here. Then you will use that one for analysis and design. The other one, response spectrum, similar. That's also according to the codes that you can add some functions that representing the acceleration for the seismic load. So those are possible that you can do it beside the auto lateral. You can bring some things that you have it. Those are the data, they call them, the data here. So if you change those data, the curve is going to change. And it's a recorded case that you can enter. So you'll be able to add something from a file, modifying it, so things can be done to the history or the spectrum that represents the seismic behavior. Okay, I'm not going to go for those. We'll just go for the auto lateral, but for this course will be enough here. Well, within the define we have spring properties, which basically will be used to represent the soils, and we have soil profile even here, but I'm not going to design a foundation within Etabs. It can be, but because they have a different program that you can transfer things from here to their own program safe that's made to design foundation. You can provide the soil properties, isolated column footings, many things that you can. This is mainly for the foundation. This can be used for the foundation here. Section cut, I might come back to it later. The rest for now, I need to explain them. So that will be enough for the define. So far we had the grid line define. Now in the next one we'll start modeling. Since I have the material, the sections, everything ready, so I can go for drawing the model that we have it.